recording also. Hello, everybody. Again, thank you so much for joining us. Nice to see we've got a good group here ready for a discussion and to hear a little bit more about evapotranspiration. I'm really excited for this discussion. I know it's one that's pretty cross-cutting, and we've got a lot of people interested in hearing how we can inform irrigation with evapotranspiration data. Perfect. All right. So I know we had a short break. So for those of you who are joining us again, I hope you stretched your legs, got some water. Thanks for coming back. And those who may be joining us for the first time, welcome to Lab to Land, Advancing Water and Soil Resilient Research for Agricultural Resilience. We've had a really awesome morning full of discussion, for presentation and question discussions, which have been all focused around the theme of water, hearing from co-governance all the way to specific weather monitoring projects, which kind of brings us into our final topic of the day with Dr. Thorsten Knipfer and Dr. Andy Black, who will be talking about evapotranspiration and kind of plant-based approaches to optimize irrigation. So I guess a bit of context for this is, figuring out how to irrigate efficiently is actually a very complex research question, and it involves an understanding of real-time interactions between plant needs and soil moisture and climatic conditions. So this discussion, I hope, is a place where we can kind of hear a bit about the science, connect with the researchers who are at the forefront of investigating really what's happening at the plant level, and then kind of consider how evapotranspiration data could inform management. At the end of this session, we'll have a chance for kind of smaller group discussions, and we'll open breakout rooms. And these can be a continuation of this discussion or just an opportunity for you guys to connect with each other and build out your network. So without further ado, I'd like to give a warm welcome to Dr. Thorsten Knipfer, who will be starting us off on this topic. Thorsten is a professor in the Applied Biology and Plant Science program at UBC Vancouver, and he leads the Plant Water Relations Lab at UBC, where his research focuses on understanding how drought affects woody perennial crops. And he really uses a mix of new and traditional methods. He studies how water stress and recovery impact plant performance. And through all this work, he's really kind of working towards developing sustainable water-saving practices. So really excited to have you here, Thorsten. I'll just give a plug as well. Thorsten is offering a webinar series kind of concurrent to this workshop throughout the late winter and into the early spring. So you'll receive some information on that if you'd like to learn more. And thanks again for just putting up your responses to who's joining us in the room today. It really helps us tailor our offerings for next time. Perfect. All right, so Thorsten, I'll pass it over to you. Looks good.
Screen, okay?
We can.
Okay, yeah, thank you so much, Asha, and also BCA Karn for organizing this event. It's a pleasure to share some of the experiences we gathered over the last couple of years into plant-based measures and evapotranspiration measurements to inform or optimize irrigation approaches. So what I would like to do is I would like to give you a little bit of a background why we actually should care about to optimize irrigation. I would like to give you some concrete examples of measurements of evapotranspiration and plant water status to show you how we can interpret these measurements. And then I want to lead into this discussion of why we believe that an ET network would be very useful for the region here. Okay, so for those of you who wonder where we are located, we are located here at the Faculty of Land and Food Systems at the UBC Point Grey campus. Our faculty's mission is to promote sustainable agriculture, improve food security, and also build climate resilient food systems where the usage of water directly feeds into. We have conducted extensive research over the last couple of years in the Fraser Valley, and specifically on woody perennials, as you can see here, on hazelnuts. That's what I will use also as an example of showing you some data today. So, but first of all, why do we even care to optimize irrigation, and what are some of these motivations that we have or growers might have? So one motivation will simply be for a grower that, you know, they want to worry less about their plants when they're on a holiday break. So the question arises, like, for how long do I need to run my irrigation lines to not come back and end up with my crop that faced some pest pressure or any sort of damage related to dry soil conditions. On the other hand, optimizing irrigation will also minimize pruning labor. That's so because trees invest less resources into the vegetative growth or the development of shoots and leaves when they are under a slight water deficit. We can also reduce fertilizer costs when we optimize irrigation by limiting the runoff of nutrients and the leaching of nitrate through the soil. We can improve the quality and the yield of our crop and the nut quality and yield if we're working with a high-value nut crop. That is so because the tree invests more resources into reproductive growth under a small water deficit. One important aspect about optimizing irrigation is also that we protect our water quality of aquatic ecosystems. So by limiting the nutrient runoff into rivers and associated streams, reduces the growth of algae that will prevent any sort of harm to fish or aquatic organism related to reduced amounts of oxygen levels in the water. And ultimately, we improve the climate resilience of our trees by making them stronger and having deeper root systems to access water at deeper soil layers. So I think some of these points may resonate with one or the other here in the audience. So if we are convinced to optimize now irrigation and we want to schedule irrigation, and by irrigation scheduling, I mean specifically of when do we irrigate, how much do we irrigate, and how frequent we irrigate, what do we want to target? And there are a lot of different choices. One is we can monitor the soil by installing soil moisture probes. We can monitor the crop and its productivity by evaluating its water status and measuring its stress level to dry conditions or hot atmospheric conditions. But on the whole field scale or orchard scale, the one method that probably resonates most with all of us and is most applicable is the monitoring of evapotranspiration, or ET, how it's typically referred to. And I want to think with you a little bit more into how we can use these ET measurements and how we can connect them to crop productivity and quality. So here are some data that we collected this growing season with a ET station we installed in the Fraser Valley in a hazelnut orchard. And this is a collaboration with multiple researchers here at UBC LFS, contribution of Andy Black, Mark Johnson, Simone Castellari, and Sean Schmuckler, and Stephen Bristow, who is the PhD student who collected those data and is crucial to this research that we're doing here. So in this picture here to the left, you see our ET station that we installed. And I want to draw your attention specifically for today on that LI710 sensor that is installed in one of these crossbars that allows us to get information about orchard ET and VPD or vapor pressure deficit on a regular basis in a relatively cost-effective way, considering that these Li710 sensors cost about $5,000. So what we observed is, since we started running the station at the beginning of July until the beginning of October, is that ET, as it is expressed here in millimeters, and all of these peaks here are 30-minute averages of ET measurements, that ET is not constant over the growing season. And that may be very, you have experienced similar things probably yourself before. And since it's not constant, and the water loss over the orchard surface depends on the time over the growing season, we need to understand where these variabilities come from in order to adjust our watering and replace this amount of lost water over the orchard surface. One variable that is the main driver of ET is the vapor pressure deficit, or the VPD. And you can see in this graph below that these fluctuations in ET are associated with changes in atmospheric demand. That means changes between a hot and dry day, where the VPD reaches values of about 3 kilopascal, to like wet and cold days, where the VPD reaches values that are close to 0. But this is not the only driver of changes in ET that we should consider. The crop itself plays a big role in affecting ET and the water loss over the orchard surface. And that is so because the crop can regulate its water loss through the opening and the closing of the stomates, as you can see here on that left picture. When the stomates are open, water will escape the leaves and the canopy. When the stomates are closed, that is no longer possible. By taking some of those data that we collected over this growing season, and we relate ET with our VPD conditions, we detected that ET is not linearly increasing continuously as VPD goes up. And at a certain threshold, the increases in ET become less and less. That is so because the stomates in the leaf can be sensitive to high VPD conditions, where the plant simply shuts down. And even under fully irrigated conditions, those stomates will not open again. That means that higher irrigation input will no longer improve crop performance. On the other hand, we need to consider that ET, or stomata behavior, as I mentioned earlier, also depends on how dry our soil is. So in this graph here, you can see on the top panel increasing soil dryness, and it is expressed here as the more negative pre-dawn water potential that was measured on the plant, and on the y-axis you can see the conductance of the stomates. And on the panel below, you can see a similar plot, but instead of like having the data now on an individual leaf, it represents the ET that was collected on the canopy level. In both cases, again, there's a certain threshold of where those stomates at the leaf close, ET is reduced, that we should consider when informing irrigation using measured ET. So we need to be aware of the crop behavior, and by crop behavior, I mean the growth, the regulation of its physiological processes over the growing season, to correctly interpret these ET measurements that can be done using different types of approaches that we can discuss a little bit later in this session here. So one thing I wanted to point out to you, what we observed from our preliminary screen of our data this season is that a reduction in ET was associated with decreasing soil tensions related to increased amounts of irrigation. That points out to us that there's potential of saving irrigation water since the crop itself probably started to regulating its water loss. So how can we then account for these BPD and soil effects influencing our ET and our crop behavior? That brings me then into paying attention to plant monitoring and understanding the plant water status. One approach is to combine ET measurement with plant-based measurements, as shown here, for example, with stem water potential. Stem water potential tells us about how stressed our crops are. Here on the graph, you can see a stem water potential of a crop that was collected over the growing season under fully irrigated conditions in this black line. The black line also shows you these fluctuations here. These fluctuations are not caused by any soil dryness. They're simply representing the different BPD conditions over this time. On the other hand, you can see here in red color a similar stem water potential line that now reflects the VPD plus the effect of a very dry soil at stomata closure. By putting these two lines together, that will give us the margin of how much we can actually improve irrigation and where the margin is to optimize irrigation and establish regular deficit irrigation strategies. What the correct level is will depend on our ability to understand the physiological performance of the crop we are interested in over the growing season. So that slide sort of concludes to us what the crop can tell us about irrigation needs, what we don't know from an ET measurement. So the target should always be to optimize crop performance by saving irrigation water at the same time. So that window of optimum performance is pretty much bordered on each side either by two wet soil conditions or two dry soil conditions. Two wet soil conditions causing anoxic conditions that result into cell damage at the root level, as you can see here, these little root cross sections with these open pores. On the right side here, you can see what is happening when we have two dry soil conditions in terms of the physiological performance of the crop. We reach the threshold of stomata closure, as I mentioned. The leaves will lose its pressure, it loses turgor, the leaves will start wilting. And then further down the line, we reach the stage of crop mortality that is not preferred by any grower. So the physiology will really allow us to understand that window of optimum performance and let the plant tell us when the irrigation is needed. But the question is always like, how much is needed? And that's where some of these other approaches come in, and specifically the monitoring of ET that will inform us of how much water we should replace at any given time over the growing season and at what time during the growing season. So method integration plays a huge role of making sense out of all these data that we collect with these ET stations. So this slide I put up there because I think at the essence of all of this is a good understanding of what accuracy and precision means. And I'm saying that because when we talk about irrigation, the next thing that comes into mind is always precision irrigation. But precision is only one part of the story, and accuracy is important because the accuracy reflects the crop performance as it is shown here in this schematic with this diagram of the dartboard. So you can see here that if you would imagine that these different axes here are the darts thrown at the dartboard, and our bullseye is our optimum performance or water status of a tree or a crop, that we can have different irrigation amounts and it may vary, but if on average we hit the bullseye, we can improve crop performance. On the other hand, if we would be very precise, and I've shown you this here on the right side, if we are very precise, with then also applying amounts of water, and we are precise about the timing, then we can reduce the amount of water application and also be more mindful about our irrigation practices. So bringing those two lines together, precision and accuracy, is pretty much at the essence of integrating between the physiology of the crop and our monitoring efforts in terms of ET. So because knowing these amounts of water loss that need to be replaced, there's quite the incentive that it would be super useful to have an ET network installed that can connect between different farms and grower sites of making better large-scale recommendations about ET and water loss and how much water the grower needs to replace at any given point in time. And I think that should be something that we will discuss in more detail now in the next 30 minutes or so. All right, so that sort of like concludes what I wanted to show you. I think this kind of set the stage a little bit for the presentation. I know that there are a lot of experts here in the room have done ET monitoring that can contribute to this discussion. And there are also others that are interested of simply learning more of how we make sense of ET data and improving our how we use our water sources more wisely. Anyways, I will leave it here. Thank you, Asha.
Perfect. Thank you, Thorsten. I always learned so much from your presentations, and I just like how you framed it as kind of moving towards this collaborative effort. And in terms of questions for the group, I think what we're going to do is I'm going to welcome Dr. Andrew Black, who is a professor and researcher out of UBC as well in the soil physics and biometeorology group. And he's going to just build on Thorsten's discussion around an ET monitoring network. And then once that little presentation is done, we'll just jump into questions for the both of you and have time for discussion. So Andy Black, I'm going to invite you to unmute and I'll just put up some slides for you. Oh, perfect. You got it. Good to go. Great.
Is it up and running?
It looks good. Take it away, Andy.
Okay. Well, thank you very much. I'll try just to make just a few points. I mean, I think Thorsten has made a tremendous important point in terms of the integration of the soil, the atmospheric demand, and in particular the plant response. I think we have to look at all three of those in order to know more about how to efficiently apply water to our crops. If you see my first slide there, see, I'm seeing a little message, start my video. What does that mean?
Maybe hit that, Andy.
Should I click that?
Yeah, go for it.
Okay, I've clicked it. Perfect. Okay, so over the last year or so in ACARN, we've been discussing the discussion about an ET monitoring network has come up, and sort of the ambitious idea would be to have key stations in at least 4 key areas in the province, and I've listed them on the right-hand side there. So in particular, the Okanagan, really important, and central interior Kootenays and the lower Fraser Valley. And in the lower Fraser Valley, we've done quite a bit of work in terms of measuring ET from various crops. And of course, we're really excited now about the Thorsten Station and what we learn about the hazelnut orchard. So I think that's really important stuff. And just a justification for what we're doing here is we really want to refine our crop water use factors, basically trying to make sure that that we're estimating water use accurately so the grower can apply as much water as is needed, but not too much. That's basically what we're aiming for here. And these stations, the idea is that they will allow us to test the relationships that that Thorsten has been talking about between crop water use and the weather variables that Andy has been talking about this morning, Andy Nadler. So this is our aim, and you can see the little graph here on the left-hand side showing the crop water use factor and the fact that it can vary through the growing season, and we should try to be conscious of that in terms of application of water to our crops. Now, just a couple of points I wanted to make, and that is that there are various ways to go here, and the picture on your screen at the moment is what we would call a relatively expensive research grade eddy covariance system. There are probably over 800 of these sites around the world currently running over forests, wetlands, agricultural crops. Basically consists of a sonic anemometer, a gas analyzer, and of course a data logger. We always have to have a data logger somewhere in the picture. This is a relatively expensive eddy covariance system. And as I've been saying, we have used this in a number of crops, particularly in the lower Fraser Valley. So what's exciting about what Thorsten is doing is the fact that at his site, he is using a relatively new instrument. It comes in at less than $8,000 Canadian. This is pretty exciting, really. It is an eddy covariance system. Sound waves are sent between these two little probes here, and that gets us the vertical velocity, which we need to calculate those fluxes. And in here we have a humidity sensor. So this is quite a remarkable little instrument. It measures the vertical velocity of the eddies, the humidity. It gives half-hourly ET values very conveniently, and it really has potential for use in an ET network. So that's what I'm kind of excited about. That this really gives that possibility at this level of funding. Now, just a couple of more points I just wanted to make, and that is the sort of work that Kirsten Hannon is doing up at Summerland is something that we should also consider, because this instrument that some of you may be aware of it, it's an atmometer. It's called an atmometer, and it's a very simple thing. It's really a wet ceramic surface. It evaporates, and a farmer, a grower, a researcher can measure the amount of water that is extracted from this reservoir, and from that we can determine what we call the potential evaporation. So this is something to be taken seriously, because maybe that's another way of developing a network. Now, we have to remind ourselves that this is not actual evaporation. This is potential evaporation. But as Kirsten has done very nicely, and she gave a talk on this just yesterday, actually, in Thorsten's webinar series, explaining how she uses the atmometer data, the potential evaporation data, coupled with how much water she puts on the crops in order to develop the actual estimation of water requirements. And she's been relatively successful. So that is something to be considered, and considering it's relatively inexpensive at around $500 an instrument. This is something that maybe we should also consider as a way of extending the measurements to multi growers. That's because we're not going to be able to use these actual evapotranspiration measurement sensors everywhere. We have to use them at key locations in order to confirm that we know what those relationships are. So I think that's pretty well it, except to make the point that where we have an evapotranspiration network, we mustn't forget the soil and some of the atmospheric variables that Andy was talking about. And the important thing about measuring the soil is that we can start seeing what the soil water is happening, how much water we have in the soil, and that's where we can use the water balance. We need to have all those components of the water balance. That's what's exciting about the network. We can develop a full water balance procedure, and that I think will go a long way to confirming our relationships that the grower can take advantage of. And in terms of future actions, I think we need to identify potential sites, decide on the kind of crops that we would use in an endeavor like this. We obviously got to consider the funding and how many sites we could afford to put up. And then I'm always harping about this. We need more measurements of ET in different crops. And the very important thing to make a point about is we need continuous multi-year measurements. So I'm really hoping that Thorsten's work can continue, not just for 2 years, but for 5 or 10 years. That's what we need, because the weather is changing and the variability is marked. 1 year is so different from the next year. So we need the multi-year measurements. And this all goes to developing our models, improving our estimation of crop water use factors. And as you can see in the very final point here, I'm a strong advocate of making sure we have those stomata resistance measurements that Thorsten makes, plant water potential measurements, so we can really properly interpret the measurements that we're making. So I think I'll end it right there. I'm sorry if I've gone over time. Thank you.
Not over time at all. Thank you so much, Andy. Really appreciate the presentation from both of you and the context that you've given to, where we might want to move on this. So before we actually get into the Q&A and the discussion on this particular topic, I just want to flag to everyone in the room that I'm going to open some breakout rooms. And you've got a couple options for the remainder of the session. If you'd like to participate in the discussion on this topic and ask questions to Andy and Thorsten, please just stay in the main room and we'll be hanging out here. There's also several breakout rooms based around networking around different themes. You're welcome to self-sort into those rooms and just make connections with other folks in the room, as well as a room where you can connect with our ACARN manager, Love SC Chile, if you have any questions about ACARN. So I'm going to open all the rooms for you, and feel free, I'm not going to assign you to anything. Feel free to self-assign if you feel interested in any particular one of those. But of course, we are just going to be staying in the main room as well and have a discussion around this topic. So in terms of participating in this discussion, we are in meeting mode, which is great. So I encourage you to unmute. But if you'd like to ask a question, it'd be great if you could just raise your hand and we'll go from there. So maybe we can start off with a question in the chat. I'm just going to go back here, maybe for Thorsten, one that came up a little bit earlier. So from Lynn, is there any data that compares production using ET for irrigation decisions against a check block that does not use ET, for example, yield quality or maturity date?
Yeah, I'm not aware of any particular study that made this comparison. So I cannot even comment much on that. I think there are certainly studies available in the literature where ET was used as a guide of establishing irrigation trials. So, for example, irrigating at a certain percentage of lost ET, and evaluated yield accordingly under these conditions. So there you will find a bunch of literature on that.
Perfect. Thanks. Reg, go ahead.
Yes, hi, Doctor. So I'm very interested being from the Peace River region, which we've seen on one map, but no discussion from the Peace region. Regarding, the amount of research that's being directed in that particular part of BC, it's just recommended about having more about soil moisture indices, different crop types. I'm a budding Haskap producer. It's a growing industry in BC. I could see a whole kinds of other potential in horticulture besides the main crops, of course, that are growing up in the north, the grains and livestock production. So I'm interested in what baseline research either the ministry is doing or through the university in the north.
Yeah, great question. Andy or Thorsten, do you want to take this one?
I'm not sure what the ministry is doing on this currently, other than making sure we've got weather stations that have the kind of data that can take us quite a long way in terms of making the calculations. Many years ago, I was involved in quite a large study involving evapotranspiration from really that was focusing on community pastures, as it turned out. And there we were looking at the relationship between water use and productivity. And it was really quite interesting, actually. There was really a strong linear relationship between water use and productivity. But that's a number of years ago. And I think it would be great to be doing that kind of stuff on some of the cereal crops and other crops in your region.
Yeah, I think specialty crops, and it's very important. We are looking more and more at irrigation. I'm a water stewardship agronomist doing water management plans through the new programs in the past few years. I see a real demand for better information, and really kind of have to wonder whether the water calculator is really got enough, ground truthing done with the changing in drought conditions to reflect, these changing conditions and different crop types. So just a vote for ministry people that are listening in to perhaps convene a circle of discussion on that.
Absolutely, absolutely. I should put another star on that map.
Yeah.
And I was a bit conscious of not putting it there. It's just that we just a little. Anyway, you made a really good point. Thank you.
Yeah, thank you.
I'll follow.
I want to comment as well, Reg. I mean, we know that there is a big skew of agricultural research and funding dollars towards the South Coast. This is something that we at ACARN are very acutely aware of because we're a provincial network. And I guess, if you have more questions about this or maybe opportunities for collaborating, ACARN as a multi-institutional network, we are working hard to kind of, take a more equity-based approach and we can connect these research collaborations across universities across the province. So certainly with more specialty crops and berries happening in the North more, we would love to facilitate connections between our South Coast berry and woody perennial researchers like Thorsten. So I would love to connect after on this and really hear you around the lack of good information where you're at. So thanks for being here.
I'm on the sabbatical. I'm the guy that's in southern France right now. So
wow, that sounds nice.
I'm having wines from a different kind of berry.
Wonderful. Well, either way, it's great. Perfect.
We'll talk to you again soon. Thank you.
Awesome. Thanks. Hans, go ahead.
Yeah, thanks. It's really interesting. I'm interested in applying ET to perennial crops. And in my case, I'm growing grapes. But I think you might actually have to adjust the ET to the phenological stages of the crop. As an example, many people in our sector have sort of applied deficit irrigation already from fairly early on in the season. And it turns out that this might actually have long-term effects on crop yields without really having a benefit to crop quality. The other example is as we face more and more extreme heat events, we do actually need to adjust often our irrigation to over 100% ET, just so that we have sufficient amount of moisture reserve for the plant to actually be able to cool itself over an extended period of time. And I'm not quite sure how in practice this can be incorporated into, ideally, eventually we would be able to kind of develop a system that is fully automatic, right, based on ET. But right now, I don't really see this happening very soon, because that this could become really, really complex.
Maybe I can comment here. Yeah, thank you, Hans. If I may, can I comment on Hans's?
Yeah, please go for it.
Yeah, I think you pretty much emphasize the importance of understanding the crop itself and what it does over the growing season, of making sense of these ET measurements, and the importance of having crop coefficients that are meaningful. The hot and dry conditions and these extreme heat events during the summer, I think so too, that this will be something we need to understand in more detail, and specifically how this affects the water loss from the plant. Because my worry is, and you do certainly have all the experience, that if you get into conditions where those plants don't transpire much anymore because the stomates are closed or partially closed, we replace a lot of, or we put a lot of water into the soil that may not be needed at that point in time. And the question may be then, okay, where does it go? Is it then just simply evaporating again? So I think these are, in my mind, important questions to address. How it certainly makes the whole automation of the approach more complex, because now we're not just thinking about the soil replacing, being mindful of these tensions in the soil, but now we also have like these hot air conditions that we sort of like, integrate into our system. But I think the most important thing is to start having this conversation, and potential future users of an approach like this are aware of these different factors, and especially learning from people like you who have like this long-term experience growing crops in some of these regions that we as researchers just simply don't have. So so bringing people together, I think is just, it's just important.
Another factor that we are interested in that could be combined with the ET is the leaf temperature differential between the leaf temperature and the ambient temperature. As an indicator, I think this could actually be quite valuable in combination with the ET as well.
Yeah, absolutely. Thanks, Hans. I think, as Thorsten said, I think having producers in the room, it brings us together in the way of like why we're doing agricultural research, who it's for, the things that we really need to consider. So appreciate you bringing those perspectives into this space for sure. And, navigating the science with expertise as well. I'm just going to look into the chat at the moment, but I encourage folks to keep raising their hands to unmute. But we've got a question maybe for Thorsten around what would be the best approach for irrigating greenhouse crops, like is reference ET based calculations versus vapor pressure deficit, like what are you doing in your research?
Yeah, greenhouse conditions, I guess it depends a little bit on the scale of the greenhouse. I believe if you can keep those environmental conditions fairly constant during this period of growth, you can probably get away with working with reference ET, having an adjustment factor associated to it that is specific to the crop. But again, it depends on how well a greenhouse can, take care of these fluctuations in VPT temperature or relative humidity. That would be sort of like my take on that. I don't know, Andy, do you have anything else that comes to your mind here? Or?
No, except I think in some of the greenhouse situations, we have one advantage of it being a controlled environment, and we can often get good estimates of how much water crops are actually using, and that can be very helpful in terms of conducting research.
Yeah, absolutely. Okay, we've got lots of questions in the chat, so maybe Andy and Thorsten, you can keep an eye on there too. But I've got a couple here that I guess are somewhat related, but maybe back to the weather stations a little bit. There's a comment that the Davis weather stations can measure a suite of variables, including soil moisture, and provide a calculation of potential ET, and then they can connect to irrigation systems and are easy to look at data. Just wondering if either of you can comment on that like potential ET calculation that's in BC.
Well, yes, those stations are excellent and do enable us to make that calculation of whatever you want to call it, potential evaporation or reference evapotranspiration. And as long as those stations have the full complement of the meteorological variables that Andy talks about, including radiation, then that's important, that's strong. And but it remains to come up with that crop water use factor that goes along with those measurements. So I mean, I think any station, particularly those that Andy's watching, I think have the full complement of the meteorological variables required to compute the potential or reference ET. From there, we need to get to the actual ET, which is what then the network is really all about. It's helping us get from those really good calculations to the actual water use. So I think we're very fortunate in having having our weather stations up to speed in terms of having the full complement of the meteorological variables being measured.
Mm-hmm. Great response. And then I guess, again, on the topic of kind of weather stations, we've got a question around why not use the Bowen ratio method for ET monitoring, like adding equipment onto existing weather stations.
Nothing wrong with that. That's a good approach, and it's been used over the years. And if someone wants to use the Bowen ratio approach, it just involves measuring the humidity gradient, the temperature gradient above the crop with some net radiation, and I think you've got a really good measurement there. So if I have a colleague in Manitoba, Enrique Camvale, and he uses that and uses it very effectively. So you know, I'm almost a fan of that. I spent many years using that approach, and it's a good approach. That's my view on that.
Yeah, for sure. And I think, when we're talking about kind of making the leap from you know, the data that we do have into like actual ET data and building that into a network. I'd say as researchers, you know, this is kind of a good space for this like priority setting and, you know, how we want to kind of make the case for moving into this more robust data. Thorsten, I'm not sure how much you're working on this at the moment, but there was a question about like kind of going back to adapting crops, whether there's any genomics work being done that looks at the control of physiological responses to drought, like reducing stomatal sizes, control of stomatal opening and closing, root depth, all of those kind of things. And, you know, when we have that kind of combined with ET data and irrigation, you know, what's the, I guess, prognosis on, you know, the time frame really for this work?
Yeah, that's an excellent question. But it brings me immediately to another point, and that has to do with the selection of varieties that are currently available to us. So we're having access to varieties that provide different yield, have different quality attributes. You know, I can make examples for like different grapevine cultivars or like different tree cultivars. So there were a lot of breeding has been done in the past in order to select for varieties that either have higher yield, better quality, but also being resistant against pests that typically occur. So my argument would be that if we understand the performance of these available varieties at that point in time better, and we're able to make recommendations to growers of what to use in a specific region, under what soil type, under what type of weather condition, in the short term, that is probably the best solution of having a more climate resilient crop, of better understanding what we have before we develop something new. You know, I can make one example. For example, if we dealing with a woody, a tree crop, for example, or a woody perennial, it takes decades from identifying a genotype of bringing this into the market. It's a long process, but our climate is changing very, very rapidly. And we need to come up with approaches and ideas that allow us to solve these problems more in the short term than
Yeah.
On the other hand, yes, that is a really good question, and there has been there's information around on different types of genotypes and how stomata density can be sort of like adjusted based on these genetic signatures.
Yeah, for sure. I think it's the long game, really. But the time that we have, as you say, is much shorter. So looking at potentially, you know, keeping doing that work, but looking at other ways that we can, yeah, support resilience in the shorter term as we adapt to the changing climate. Okay. Perfect. I'm glad you liked that response. All right, everyone. We are just going to wrap up for today. I encourage you, if you have any last minute questions, you can put them in the chat and we'll follow up with the responses from Andy and Thorsten. But overall, I just want to thank you so much for joining us today. I've really taken away a lot from our sessions. I'm always so impressed by the quality of the questions, the thoughtfulness of the discussions, and like the willingness to engage with the presentations. So I appreciate you all taking the time out of your day to join us. And I will note that this is a 2-day workshop, so we will be back tomorrow morning for more. At 8:45 a.m. we will be going over several soil-related projects, so looking at kind of another suite of climate adaptation and mitigation. We'll have a presentation on restoring Indigenous forest gardens and looking at the influence of ancestral stewardship on soil processes. We'll have a panel discussion looking at farmer-led soil research for climate adaptation and mitigation with 4 projects across the province. And then we'll have another discussion kind of similar to this one on bringing soil biology testing on farm and looking at kind of the expectations we can have around improving soil biological health through management and amendments, and another kind of networking opportunity. So for tomorrow, I'll note the Zoom links are all the same as today. So wherever you found them today to join in, they will just be the same. I encourage you to connect with us. You can scan the QR code to receive any information about our upcoming events, research briefs, quarterly newsletter, all on the theme of agricultural research across the province. And in the chat as well, I'll note there's a feedback survey that'll get in there that, as mentioned, we really appreciate you taking just 1 minute to fill out. It really helps us tailor our future offerings and make sure that it's stuff that you guys would like to hear and like to participate in. I'm also going to drop in the program for all of the sessions. It's available on our website, has all the speaker descriptions. And I guess last but not least, just to round out this water topic, I'll drop in a link to our 2024 workshop where we had lots of water sessions and really dug kind of, in a different way into the topics that we've been in today. So if you'd like to learn more, I encourage you to check those out. But other than that, I will let you all go. Really, again, appreciate you coming. It means a lot to us. We really like connecting with you in this way. So I hope you have a great rest of your day, and we hope to see you tomorrow. Thanks.